Hello everyone. In this video we are going to learn about capillary. Now what is capillary tube? A tube of a very fine bore is called capillary tube. That means a tube which has very fine small radius, that is called capillary tube. Let's see what is capillarity. Capillarity, it says that a phenomena of rise or fall of liquid in capillary tube is called capillarity. That means when you dip any capillary tube in a liquid, it may happen that the liquid may rise or the liquid may fall. That phenomena is called capillarity. Now, why the phenomena occurs? The phenomena occurs due to the adhesive force between the surface of the wall of the capillary tube and the liquid. If the attractional force is there, then due to the attraction the liquid may rise, and if there is no attractional force, then the liquid may uh, fall on the capillary tube. It is called that if the liquid can wet the surface of the capillary tube, then it may rise, and if the liquid cannot wet the surface of the capillary tube, it will fall. So the phenomenon of rise or fall of liquid in a capillary tube is called capillarity. Now in this picture, if you zoom it out, so you can see that the shape of the surface is look like curved surface at towards the wall of the capillary tube, here also, in here also. So here we have taken the example of water, and here we have taken the example of mercury. So mercury cannot wet the wall of the capillary tube, that is why it go down from the surface of the mercury outside, but here the water can wet, so it rise upward. Now here you can see this area is little bit curved, so the surface tension always acts tangentially. So the tangent of the surface of the liquid makes an angle with the capillary tube. So that angle is called angle of contact. So here you can see the angle theta, which the tangent to the liquid surface at the point of contact, this is the point of contact, makes with the solid surface inside the liquid is called angle of contact or capillary angle. So that angle is also called capillary angle. So here you can see if the angle is less than 90 degree, so the liquid will go rise upwards, but if the angle is greater than 90 degree, the liquid fall. So this is called angle of contact. I hope you understand. Here we are going to find the rise of liquid in the capillary tube. Now here you can see the rise of liquid here, because we have taken water as an example. Now let us find the volume of liquid rising in the capillary tube. So what is the volume? Let's find it. So here you can see the height of the liquid, we have taken that h, and here this is the meniscus, and here also some liquid is present. So the volume of the cylinder is pi r square h, where h is the height of the capillary, where h is the height of the liquid column. And in this position also some liquid is present, in that position also some liquid is present. So what is the liquid? What is the volume of the liquid? The volume of the cylindrical shape. So the volume of the cylindrical shape is pi r square r, because the radius of that sphere is r. So pi r square r is the volume of the cylinder, but in that position there is no liquid, so we have to subtract that volume. So the volume is half of a sphere, so that is 2 by 3 pi r cube, we have to subtract. Now if we calculate that one, we will get that the volume of the liquid is this, because pi r cube minus 2 by 3 pi r cube will be 1 by 3 pi r cube. Now if we take pi r square common, so we will get pi r square into h plus 1 by 3 r. That is the volume of the liquid present in the capillary tube. Now what is the weight? Weight is the volume. Weight is the volume into density into acceleration, because volume into density is mass, mass into gravitational acceleration is weight. So pi r square h plus 1 by 3 r rho g is the weight of the liquid. Now weight is always acting downward. Weight is acting downward direction, but still here there is some upward force, that is why it is in equilibrium. So what is the upward force here? Here you can see the surface tension acting always inside as a tangent. Now this is the theta, and it is the surface tension always acting as a tangent from in the direction of the tangent of the surface of the liquid. Now the surface tension always acting from each surface, means from this way, means all over the circumference the surface tension is acting. Now from the Newton's third law also there is a reaction force, so we can write is as a, suppose the surface tension is T dash, so the reaction force we can write as T. So this is the reaction force of that surface tension. Now this is also making an angle theta. Now the upward component is T cos theta, T cos of theta, and the vertical and the horizontal component is T sin theta, T sin theta. Now T sin theta in this direction also T is acting, but T sin theta is acting in that direction, and upward is T cos theta. Now through all over the circumference this tension is acting. So sin theta is horizontal and opposite with each other, so sin theta part will cancel with each other, but cos theta part will sum up, so that the total upward force is T cos theta in this direction, T cos theta in this direction, and all over the circumference. So we can say the total upward force is T cos theta into the circumference. So T cos theta, the total upward force is 2 pi r into T cos theta. I hope you understand that thing. 2 pi r into T cos theta. So this upward force will balance the weight which is downward. So weight is always acting down and this is acting up. So this will balance with each other. So we can for equilibrium condition we can write total upward force is the weight. So total upward force is 2 pi r cos theta and weight is this one. Now if we want to calculate T, so T will be see here pi will cancel each other, r square r will be there, and rho g is there, 2 will be at the bottom of this one. So T we will get, that is r h plus r by 3 into rho g divided by 2 cos theta. So this is the tension we have got. Now if the radius of the capillary tube is very small, see the radius is very small comparing the h. As compared the h, radius is very small, so we can write that h plus r by 3 is equals to h almost, because suppose h is 1 meter and r is 0.1 millimeter, so r is very small, so we can write that h plus r by 3 is h. So if we write this, so it will be r into h into rho into g divided by 2 cos theta. Now from this equation we can get the value of h, which is h equals to 2 t cos theta divided by r rho g. This is the rise, this is the height of the liquid column. So this is the rise of the liquid column of a capillary tube. So this is the formula. Now here you can see from this equation we can get some conclusion. What are the conclusions? If the theta is less than 90 degree, so if the theta is less than 90 degree, then cos theta will be positive. So if cos theta is positive, then the height is positive. So if the theta is less than 90 degree, suppose this is the wall and the theta is less than 90 degree, so the height of the rising, the height will be positive. That means the liquid column will rise. But if the theta is above 90 degree, that means in this way, above 90 degree, so cos theta will be negative, then height will be negative, so the liquid falls. So this is the equation from which we can say the liquid will rise or the liquid will fall, or if it is so, then what will be the amount of the height. So this is the rise of liquid in a capillary tube. I hope you understand that thing, that how to calculate the height of a liquid of a capillary tube. So this is the calculation. Actually, in that calculation, the weight is balanced with the upward force. So this is the total upward force, and the weight, if it is in equilibrium, so you have to equal that things, and as you equal that thing, you will get the height. So this is the simple formula to calculate the rise of liquid.
Friends, we are going to learn that if the length of the capillary tube is insufficient. So initially we have seen that if there is a capillary tube in a liquid jar, so the liquid will rise upward. So the h, which is the height of the rising liquid, is denoted by this equation: h equals to 2t cos theta divided by r rho g, where r is the radius of the capillary tube. Now the thing is, if the height is not sufficient for the capillary tube, if the height of the tube is small, then what will happen? If is the liquid overflow? We have to see that. Now for that, let us see here that this is the this is the center of that circle. So here the surface of the liquid is not like pure half circle, it is a part of a circle. Now if we draw this line, so this will be the radius of the circle. So let's say this is r, and small r is this is the small r, which is the radius of the cylindrical this is the radius of the capillary tube. Now we know, if we draw a perpendicular here, so this line, suppose this is the theta, suppose this is theta, so this will be r cos theta, isn't it? R will be r cos theta, small r will be r cos of theta. This r value, that means the radius value, is r cos theta. Now if we put this in this equation, that is r equals to r cos theta, we will get, let's see, we will get h equals to 2t cos of theta divided by r cos theta into rho into g. Now cos theta will cancel, and the term we get, that is h divided by 2t r rho g. Students, here if you just take this r on the left hand side, so rh will be 2t divided by rho g, isn't it? Now see, 2t, surface tension of a liquid is constant, rho, that means the density is constant, the gravitational acceleration is constant, so the whole term is a constant. So we can say RH is a constant. What does it mean actually that RH is a constant? That means the product of the radius of the meniscus, R is the radius of the meniscus, and the height of the liquid is constant. Now height of the liquid, or you can say the height of the capillary tube is constant, means the height of the liquid column is constant. So that means the product of these two is constant. So if the height is less, if the height decreases, the radius will increase, the radius of the meniscus will increase. So if the liquid height is increased, then the radius of the meniscus will decrease. So if the liquid height will decrease, the radius, that means if the, suppose the liquid height should be like that, but the length of the capillary tube is insufficient, so in that case the height will be decreased. Now if the height will decrease, the radius of meniscus, this meniscus should be increased, so it will be flatter, so it will not overflow. The radius and the height, the radius of the meniscus will means it is arranged such a way that it will not overflow, but the radius will increase. By that way, the product should be constant. So if the length of a capillary tube is insufficient, in that case the liquid will not going to overflow. It will just increase the radius of that meniscus. So I hope you understand all the points in the capillary tube. So this is the capillarity, and this is the process of a liquid rising or falling in a capillary tube. So if you have any question, you can ask me through my personal WhatsApp number. I think you all know, it is given in the description also. You can ask me, and if you have any query, you can ask me in the comment section also. So that's it for today. I hope you will enjoy it. Thank you everyone.